Welcome to our YouTube channel. In this video, we will dive into the secrets behind Tesla's unparalleled safety. Have you ever wondered what makes Teslas the unbeatable champions of safety on the road? Well, it's not just the autopilot feature that keeps you on track during those long drives. Tesla cars are often praised for their top-notch safety ratings, making them the safest rides on the road. It's just common sense to want to drive something that's as safe as can be, right? Is safety really cool? Of course, we can display a ton of amazing crash test footage, but will that truly be sufficient? The important point is, you can crash into anything with the Tesla and escape unharmed, which is amazing, but there are a lot of moving parts that make that happen. Tesla employs a holistic approach to ensure the safety of its vehicles, from frame design to onboard equipment. Their safety measures are constantly improving, ensuring that their products are as safe as possible, potentially even saving your life one day. Here, let's begin with the basics. The two primary objectives of a Tesla's structural parts that are designed to carry out a particular function in the case of a collision. The first priority is obviously to protect the occupant, and the second is to protect the battery pack. Even in the unlikely event that the battery pack survives an accident and bursts into flames, it would still be a minor drawback for the electric vehicle platform. The bumper beam, a piece of metal that runs parallel to the plastic bumper and rests just behind it, is your first line of defense in small collisions. It's relatively simple to replace and will withstand the impact. From there, the car has two crush cans, also known as crash rails, which are metal beams that run from the front to the back. These beams can collapse to absorb the impact of a low-speed collision up to about 20 miles per hour. When the energy from the accident hits the vehicle's primary structure, things start to get serious. Tesla designed their new front gigacasting especially to absorb and then resist the energy from a head-on collision for the first 2 feet of the casting. 3 structural ribs that go from the front to the rear are made to break easily, but as you approach the back of the casting, the ribs get thicker and thicker and are connected by a honeycomb of triangle patterns. This region is significantly stronger, and this is when the vehicle's collision mitigation technique shifts from absorbing energy to resisting. Tesla calls this controlled crushing. Now, this isn't the only line of defense built into the front end. Tesla has configured several load routes via various crush structures that are best suited for various impacts. You never have to worry about the front motor coming up into the cabin or getting pushed into the battery pack, because the lower load path, which sits underneath the casting, will divert some crash energy into the subframe. As the subframe crumples, it's actually designed to pull the front drive unit straight down and away from the rest of the vehicle. When Tesla's head-on crash test demonstrated the Model Y's strong structure, allowing easy front door opening even after smashing into a brick wall. The roof, made of specific structural glass and ultra-high-strength steel frame, can withstand over 20,000 pounds of force. Like everything else in the Tesla, the battery pack is designed for maximum safety. However, perhaps the biggest benefit of the battery pack is its sheer weight. With 1,000 pounds of battery cells placed underneath the floor, an electric vehicle can have an extremely low center of gravity, making it nearly impossible for the vehicle to roll over. Tesla's fleet data, gathered from surround cameras and a computer, allows them to analyze real-world conditions in various collisions, ensuring Tesla engineers consider all possibilities, a significant advantage over competitors. Tesla vehicles are equipped with numerous sensors, primarily focused on improving crash safety. These sensors monitor seat positioning, steering wheel movement, seat belt usage, and even measure individual weight and seat position. The car calculates airbag deployments within 10 milliseconds of impact detection using real-time computer data. The airbag system includes active vents for enhanced protection, continuously improving software-based measures. Tesla continuously runs fresh computer simulations and real-world tests in their on-site crash lab to assist them fine-tune the airbags and seatbelts for maximum safety. Recent iterations of the automatic system have improved to the point that the vehicle will now begin taking preventative action even before a collision occurs. Whether or not you are utilizing autopilot, Tesla's AI vision network is continuously active. As Elon Musk said at Tesla's most recent shareholders meeting, the best crash is no crash. And what he means by that is that the vehicle's autonomous driving features serve as the first true line of defense against a collision rather than the bumper beam or the crush can. Nowadays, every high-end car includes automated emergency braking and possibly even some automated steering. These systems can function as collision avoidance systems, but only to a very limited extent, and by the time they activate, the car has already entered the danger zone. Tesla is developing an artificial intelligence AI system that will be able to actively stop the car from ever going into the danger zone. It is an artificial intelligence neural network, and its task is to use image data from surround cameras to comprehend the surroundings of the vehicle, including the state of the road and every other vehicle that is using it. This artificial intelligence can not only locate objects in three-dimensional space and identify what they are, but it can also forecast where these objects will be in the future. The automobile can create a route through the road environment that actively avoids even the prospect of a future collision by utilizing that 3D model to identify all of the risk zones on the route. The car knows that if it enters any of those places, there will be a high likelihood of a collision. Autopilot technology can see in every direction, surpassing human capabilities. While human intervention is still needed to prevent self-driving cars from crashing, it's likely that autopilot will eventually intervene against humans in the near future.